Welcome back everyone to this lecture on self-join. A self-join is a query in which a table is joined to itself. Self-joins are useful for comparing values in a column of rows within the same table. So the reason we talk about this as advanced SQL commands instead of in the join section is because this sort of use case is more dependent on your table structure and the actual question you're trying to solve. So it's not as common as just a normal inner join, for example. So let's discuss self-join in a little more detail. The self-join can really be viewed as just a join of two copies of the same table. Keep in mind the table is not actually copied internally, but SQL performs the command as though it were. And the other thing to keep in mind is there's no special keyword for a self-join. It looks just the same as a simple standard join, and it carries the same syntax with the same table happening to be in both parts. However, when you are using a self-join, because you're using the same table, it is necessary to use an alias for the table. Otherwise, the table names would be ambiguous within the self-join. So let's see a syntax example of this in order to see what I'm talking about when I mean the same tables being joined, as well as those table aliases. So here we can see the syntax for a self-join. I'm saying select table A.column, comma, table B.column from table as table A, join table as table B on table A dot some column matching to table B dot some other column. So what's actually happening here? Well, the main thing to focus on are these table names. Notice in green here, we're saying from table as table A, join table as table B, which is me assigning two different aliases to the same table. This is what allows me to perform the self-join. The main thing to keep in mind is that even though you see representations of table A, table B, and just table here, all of these are actually referring to the same table. We're just using the aliases in order to organize this. Okay, so I think this is best explained through an example. So I want to show you a more realistic situation of when you would want to actually use this. Let's imagine that we have a company and we have some employees in this company. And employees have to send reports to other employees. So I have this table of employees with their primary key, employee ID, which is just a unique identifier per employee, then the name of that particular employee, and then the ID of the person they need to send a report to. So each employee sends reports to another employee. For example, here I can see that Andrew, employee number 1, sends a report to employee ID number 3, which happens to be Charlie. So Andrew's sending reports to Charlie, Bob's also sending reports to Charlie, Charlie is sending reports to employee ID number 4, so that's David, so Charlie reports to David, and then David sends reports to employee number 1, which is Andrew. Now let's imagine I wanted to show the results of the employee name and their report's recipient name. So I want to go from this employees table to something that looks like this on the right, where I have the name and then the person they're reporting to instead of just the report ID, which is the employee ID of the person reporting to. Technically, all this information is in this one singular table. So I can use a self-join to essentially make a copy, join it together in order to match the employer name or employee name with the report ID along with the employee ID. So let's break this down. Here again we have the generalized syntax, and let's start swapping out the components given what we want to accomplish here, going from this employees to just the name of the person they report to. So what I'm going to do is first focus on the tables, because that's really what we're doing here. First things first is we have the main table. So we already know the name of that table is just employees. So if I take a look at my employees table, that's just the name of the table I'm working with. So I'm going to replace that with employees. And now it's time to select the first alias, which is table A. So what I want for my first column is the employee name. So I want to think of this as referring to the employee name based off the employee ID. So I'm just going to refer to that as EMP for employee. Then the second thing I want to do is focus on the person they report to. So for table B alias, I'll go ahead and label that, thinking of it as based off the report ID. So I'll label that as report. Then I need to decide what column am I going to join this on. Well, recall that the employee underscore ID column corresponds with the report ID column. The report ID column was just representing the employee ID number. And then the column we actually want to select happens to be the name for both this theoretical employees table and this theoretical report table. And this is the final syntax. So this will take our singular employees table and return back the results of one column of employees and then the second column of those same employees, but the person they happen to be receiving reports from. And in order to make sure you don't get two columns with name, we can always say that second column should be as rep. So essentially an alias for that second column. That way we don't see name. Instead we see name rep as shown here. So we want results showing the employee name and the report's recipient name. And again, make sure you kind of pause and make sure you understand the syntax and how we were essentially just swapping out the tables and swapping out the aliases. Let's explore a quick example on our own DVD rental database. Okay, here we are in pgadmin. Let's imagine that I wanted to answer the question, find all the pairs of films that have the same length. If we take a look at the film table, so select everything from the film table, we have the title of the film, and then if I scroll over, I also have this length column. So what I'm going to be doing is just focusing on that title column and this length column. And I essentially want to figure out what other films happen to match up together as pairs that have the same length. So if we take a look at Chamber Italian, for example, which is the first one that I got, notice here it's 117 minutes. So if I say select title length from film, where length is equal to 117 minutes, and run this, notice that there's, besides Chamber Italian, 4 other movies, Affair Prejudice, Graffiti Love, Magic Mallrats, and Resurrection Silverado, that share the same length. But my final result, the way I want it to look, is to have 2 sets of titles and then their matching length. So essentially I want to have these paired off, Chamber Italian with Affair Prejudice, then Chamber Italian again with Graffiti Love, Chamber Italian with Magic Mallrats, and then Chamber Italian again finally with Resurrection Silverado. So how can we actually do this? Well, to do this, I would essentially need 2 copies of the same table. So this is perfect for a self-join. So what we're going to do here is forget about this where for a second, and I'm just going to run this. So we have select title length from film. First, let's decide how we actually want to format this. I'm going to pretend that I have 2 tables, film 1 and film 2, or F1, F2. So I'll say F1 title, comma, F2 title, and then I have to decide to grab the length from one of the tables, so we'll do it from F1. That way, I can get something that looks like Chamber Italian, the Mallrat one, or whatever that film happened to be called, and then, or Resurrection Silverado, and then 117 minutes. So it's going to do this for all possible pairs of films that have the same length, at least with the ones that, for the first instance, it found it in the title column. So then we're going to say from film as F1, and then we're going to do an inner join on film as F2. And this is where we have to decide what we're actually going to be joining on. So I'm going to say join film as F2 on, and I'm going to say grab film ID from F1, and I actually don't want to set it equal to F2 film ID. Instead, I want to say not equals to. But in order for this to make sense of why we're doing a not equals here, I'm first actually going to do it incorrectly with an equal sign. So if my F1 film ID is equal to my F2 film ID, and then I say and F1 length is equal to F2 length, notice what I'm asking here for. I'm basically just going to match up, for example, Chamber Italian with Chamber Italian again in the next table, or its copy. So if I were to run this, I'm just basically matching each movie with itself. So what I actually want to do is make sure that, for example, Chamber Italian's film ID doesn't actually match with any of the other film IDs in the table, but does happen to match with the same lengths. So we're going to say not equals to here. So that's the kind of fundamental difference in order to answer this question. So now when I run this, notice what happens. I get back Chamber Italians matched up with the other titles that happen to share the same length in runtime. So what I'm doing is I select Film 1 title, Film 2 title, Film 1 length from Film as F1, inner join Film as F2. So these are the aliases necessary in order to perform the self-join, and then on. And in this particular case, in order to answer the query, I had to say not equals to the film ID. But I did want to make sure that their lengths matched up. And that's an example of a self-join using that DVD rental database that we've been playing around with. Okay, thanks, and I'll see you at the next lecture.